I am J. Lokeshwari, Assistant Professor of Computer Science, ADM College for Women, Nagapattinam. Now we are see the topic is phases of compiler in compiler design. What is meant by compiler? Compiler means compiler is a program, takes a program written in a source language and translate into an equivalent program in a target language. In the figure, we are seen in the source program, normally a program written in high-level programming language. The compiler converts the source program into target program. The target program is normally the equivalent programming in machine code, that is a relocatable object file. Compiler translates from a source language, a functionality is equivalent the target language, that is a virtual machine, since the computer can understand only in binary numbers. So a compiler is used to fill the gap, otherwise it would have been difficult for a human to find information in the 0 and 1 form. The generated machine code can be later executed many times against different data each time. Of course, one expects a compiler to do a faithful translation. That means the meaning of the translated text should be the same as the meaning of the source text. The compiler for high-level programming languages are among the larger and more complex pieces of software. Original languages include Fortran and COBOL, often multipass compiler to facilitate the memory reuse. Compiler development helped in better programming languages design. Early development focused on syntactic analysis and optimization. The next one is commercially the compiler are developed by very large and software groups. Current focus is on optimization and smart use of resources are modern in RISC. RISC means a reduced instruction set computer architecture. There are two parts of compilation. First one is analysis, second one is synthesis. The analysis part breaks up the source program into constant piece and creates an intermediate representation of the source program. For example, lexical analyzer, syntax analyzer and semantic analyzer are the parts of the analysis part. The next one, synthesis part. It constructs the desired target program from the intermediate representation. For example, intermediate code generator and code optimization are the parts of this phase. Why study compiler? General background information for good software engineer increases understanding of language semantics. Seeing the machine code generated for language constructs helps understand performance issues for languages. It teaches good language design, and new devices may need device-specific languages. The new business fields may need domain-specific languages. Applications of compiler technology and tools. In processing XML and other generated documents, code, etc., then processing domain-specific and device-specific languages, then implementing a server that uses a protocol such as HTTP or IMAP. The natural language processing is, for example, spam filter, search, document comprehension, summary generation, and translating from a hardware description language to the semantic of a circuit. That is automatic graph layout. For example, graph is then extending on existing programming language, program analysis and improvement the tools. Other applications are, in addition to the development of a compiler, the techniques used in compiler design can be applicable to many problems in computer science. The techniques used in lexical analyzer can be used in text editor, information retrieval system and pattern recognition programs. The technique used in parser can be used in a query processing system such as SQL. Many software having a complex front end may need techniques used in compiler design. The symbolic equation solver, which takes an equation as the input, the program should pass the given input equation. Most of the techniques used in compiler design can be used in natural language processing systems. Then major part of the compiler. There are two parts already we are known, the analysis and the synthesis part. The analysis phase is intermediate creation between the source program, then synthesis phase equivalent target program into a created for the intermediate representation. Next, phases of a compiler. First one, lexical analyzer, syntax analyzer, semantic analyzer, intermediate code generator, code optimizer and code generator. Each phase transforms the source program from one representation into another representation. They communicate with the error handler, they communicate with the symbol tables. First phase is lexical analyzer. The lexical analyzer reads the source program character by character and returns the tokens of the source program. What do you mean by token? Means the token is a pattern of characters having same meaning in the source program, such as identifier, operators, keywords, numbers, delimiters, and so on. For example, new value equal to old value plus 12. Token, new value is an identifier, equal to is the assignment operator, old value is known as identifier, plus symbol is known as add operator, 12 means their number. Puts information about identifiers into the symbol table. The regular expression are used to describe the tokens. A finite state automation can be used in the implementation of the lexical analyzer. The next page is syntax analyzer. The syntax analyzer creates the syntactic structure of the given program. That means the parse tree is, it is called a syntax analyzer, creates a syntactic picture. Then syntax analyzer is also called a parser. The parser tree describes the syntactic structure. In a parse tree, all terminals are at leaves. All inner nodes and non-terminals in a context-free grammar. Then these are the example of parser. The syntax of a language is specified by a context-free grammar. The rules in a CFG, that means context-free grammar, are mostly recursive. The syntax analyzer checks whether a given program satisfies the rules implied by a CFG or not. If it satisfies, the syntax analyzer creates a parse tree for the given program. We use BNF to specifically in CFG. BNF means a Backus Naur form. Assignment equal to identifier, expression tends to identifier, expression tends to number, expression tends to expression plus expression. These are the rules of syntax analyzer. The next one, syntax analyzer versus lexical analyzer. What is the difference between syntax analyzer and a lexical analyzer? Which constructs of your program should be recognized by the lexical analyzer and which ones by the syntax analyzer? Both of them do similar things, but the lexical analyzer deals with simple non-recursive construct of the language. The syntax analyzer deals with recursive constructs of the language. The lexical analyzer simplifies the job of the syntax analyzer. The lexical analyzer recognizes the smallest meaningful units, that is token in a source program. The syntax analyzer works on a smallest meaningful units in a source program to recognize meaningful structure in our programming language. Then parsing techniques are depending on how the parse tree is created. There are different parsing techniques. These parsing techniques are categorized into two groups. First one is top-down parsing and bottom-up parsing. Top-down parsing, construction of the parse tree starts at the root and proceeds towards the leaves. Efficient top-down parsers can be easily constructed by hand. Recursive predictive parsing and non-recursive predictive parsing in LL parsing techniques. Next one is bottom-up parsing. Construction of the parse tree starts at the leaves and proceeds towards the root. Normally, efficient bottom-up parsers are created with the help of software tools. Bottom-up parsing is also known as the shift-reduce parsing. Operator precedence parsing, it is simple, restrictive and easy to implement. LR parsing is general form of shift-reduce parsing. It consists of LR, SLR and LALR. Semantic analyzer, the third page is called a semantic analyzer. It checks the source program for semantic error and collect the type of information for the code generation. Type checking is an important part of the semantic analyzer. Normally, semantic information cannot be represented by a context-free language used in syntax analyzer. The context-free grammar used in the syntax analysis are integrated with attributes, that means semantic rules. The result is a syntax-directed translation attribute grammars. For example, a new value equal to old value plus 12. The type of the identifier new value must match with the type of the expression old value plus 12. Then next page is intermediate code generation. A compiler may produce an explicit intermediate codes representing the source program. These intermediate codes are generally meshing. That means architectural independent, but the level of intermediate codes is close to the level of machine codes. Already we know the example. The new example is new value equal to old value plus factorial plus 1. A new value is an identifier, so we are putting the ID 1, old value is ID 2 and a factorial is ID 3. Intermediate code generator in quadruples, that is ID 1 equal to ID 2 multiplied in ID 3 plus 1. Next page is code optimizer. For intermediate code generator, the code optimizer optimizes the code produced by the intermediate code generator in the terms of time and space. For example, multiplication id2 id3 temp1, then add temp1 hash1 id1. Then next phase is code generator. It produces the target language in a specific architecture. The target programming is normally is a relocatable object file. It containing the machine codes. For example, move id2 r1, multiply id3 r1, add r1, move r1 and id1. Assume that we have an architecture with the instructions whose at least one of its operand is a machine register. The compiler and the translator design decisions. First, they are differentiating two languages. First one is choose a source language. Second one is choose a target language. First one, choose a source language means large enough to have many interesting language features, small enough to implement in a reasonable amount of time. For example, the languages are Micro Java, Decaf and Mini Java. Choose a target language, either a real assembly languages for a machine with an assembler or a virtual machine language with an interpreter. For example, Micro Java, virtual machine, MIPS, it is in a RISC architecture, then SPM simulator also. Then Crash compilation. A Crash compiler is a compiler. It is capable of creating executable code for a platform other than one on which the compiler is run. The Crash compiler tools are used to generate executable for embedded system or multiple platforms. It is used to compile for a platform upon which it is not feasible to do the compiling, like microcontroller that they don't support an operating system. Uses of Crash compiler. The fundamental use of a Crash compiler is to separate the build environment from target environment. This is useful in a number of situations. An embedded computer where a device has extremely limited resources. For example, microwave oven will have an extremely small computer to read its touchpad and a door sensor, provide output to a digital display and a speaker, and to control the machinery for cooking food. This computer will not be powerful enough to run a compiler, file system or a development environment. Since debugging and testing may also require more resources than are available on an embedded system, the Crash compilation can be less involved and less prone to errors than native compilation. Compiling for multiple machines. For example, a company may wish to support several different versions of an operating system or to support several different operating systems. By using a Crash compiler, a single build environment can be set up to compile for each of these targets. Compiling on a server farm, similar to compiling for multiple machines. A complicated build that involves many compiler operations can be executed across any machine that is free, regardless of its underlying hardware or the operating system version that it is running. In GCC, a free software collection of compiler can be set up of Crash compiler compilation. It supports many platforms and languages. Thank you all.